Good afternoon, everyone. My name is Tuan. I'm senior lecturer in design engineering at Middlesex University. I have here my colleague, Dr. Purab Shah, the director of program. Professor Tuan is director of London Military Research Center. So today we'll introduce you with the program that we are running. We start running this one in Middlesex, which is the Master in Electronics Engineering. So I hand over to my colleague, Dr. Praf, to introduce our university.
Thanks, Tuan. So, hello, everyone. I'm Purav Shah. I'm a senior lecturer at Middlesex University in the Department of Design Engineering and Maths, and also the program director for the engineering programs at Middlesex University, and electronics engineering masters being one of them as well. So just a quick brief introduction to what our university is. So Middlesex University considered to be one of the top 2% in the world university rankings. Also, we have over 300 plus undergraduate programs and 200 plus postgraduate programs that we run across global campuses, which are based in London and Mauritius and Dubai. So we have 3 campuses, and of course we have 250 plus other university and college partners globally as well. One of them being also close to, again, South Asia is ACBT Sri Lanka. So we represent over 160 nationalities amongst our students and members of staff as well. So if you can go to the next slide. So why Middlesex University? So, as we said earlier, that, we are top ranked in quite a few categories. So one of them being teaching and quality. So our teaching is recognized in terms of a silver award for the teaching excellence via the Office for Students in 2023. And there are a couple of other What Uni rankings that happen in the UK as well. And we were ranked first in London for student choice and also first in the course quality. In terms of employability, we have a fantastic team locally in London and of course globally across other campuses as well, where our employability and career focus is also considered to be one of the best across the sector. And the careers and futures, that is the name of the services that is offered across our London campus for the students. We offer one-to-one career advice, internship programs, placement opportunities, and networking opportunities. So for the MSc Electronic Engineering especially, there are 2 pathways: a normal 12-month program or a 24-month program, which includes a placement, and where students will be looking for placements. They would be going for advice from the careers and futures team. In terms of facilities, I'm a very much having looked at lots of universities across across the UK. In terms of facilities, we are world class. I must say that, and I emphasize that purely because that comes from experience visiting other campuses, other universities across in different cities and countries. We have been ranked first for facilities in 2025, which is very recent. And this is not just for engineering, but it is across all the entire sector of programs that we have at Middlesex University. For engineering, we do have quite a few good connections with industry, National Instruments, Siemens and Festo, Cisco, and Huawei. So there's quite a few places where students can get the exposure to industry standard resources. Next slide. So considering why Middlesex University for students, The advantage they get is industry standard education. So what industry's expectations are. Our industrial advisory board also includes people from industry. So we have Siemens, we have Gambika, which is a trade association. One of the key members of Gambika is also part of our industrial advisory board as well. So that leads the development of the courses very much in line with what the industrial requirements are for today's engineers. In terms of reputation, globally, we are very well known thanks to our global campuses as well. So we are located in Hendon, in North London, where this program is going to be based. It's a very nice, vibrant campus and easily accessible, 20 minutes from central London. So you take a tube and you are into Hendon, and a 7-minute walk into the campus. Our students are one of the highest graduate earners. So when they finish their education and they go out for jobs in industry, the university was ranked second in the UK for graduate earnings in 2024, which does emphasize that the quality of our education provided to our students is one of the best. In terms of as I mentioned, we represent a wide variety of nationalities within the staff as well as the students, and hence our student support and the community and the inclusivity that we have across at this campus is it's fantastic. So students who would be coming from abroad to pursue a master's program, for example, in electronic engineering, we provide a very welcoming, inclusive environment, and there are very well placed, support services that are available at our university. Students will feel at home. That is one thing because of the community relations, that exist across the university. The place where this MSc Electronic Engineering will be placed is within the Faculty of Science and Technology. And within the Faculty of Science and Technology, we have 5 departments. So computer science, natural sciences, psychology, sports science, and design engineering and maths. Electronic engineering will be placed within the design engineering and mathematics department. So I'll pass it over to Tuan now to go through with you a little bit more detail into what the program is about. Thank you.
Thank you, Prof, for a warm introduction about our university and our programs. So let me introduce you about the program that we are currently running. So first, we all aware of the wave of AIs that replacing our jobs. So the first casualties we can see that the entry-level knowledge and the software roles will be replaced very soon. We will see that around 85 million jobs replaced globally by the end of 2026, and 55,000 jobs cut directly by AI in 2025. And it is recorded that 25% of the jobs currently can be hour can be automated by AI, which is quite huge wave of things that we are only aware of the powerful of AI, and this leads to some type of jobs that can be at risk. For example, as we mentioned earlier, the data entries and admin support. At 92% of being replaced at the risk by AI. Junior software coding roles, 78% at risk. Customer service, call center, 74, and followed by content writers, finances, analysis. And you will see here it's that the electronics and hardware engineers are only 12% at risk. This is because of the fact that we're all related to the physical world, which is not replaceable by AI currently. So this is the big pictures of what's happening right now. And this is scary, but it always brings us opportunities that, you know, AI needs hardware. It runs on CPU, GPUs, and data centers based on physical world. And hardware needs engineers. So, you know, it needs chips, circuit making, communication between, you know, servers and data centers, etc. So the design and build and maintenance of those things, the backbone of AI, is done by electronics engineers. So it is, you know, AI cannot be risk to us currently. So we can see that AI is a tool for engineers, not replacement for engineers. So that is a good news for us as an electronics engineers. And what do we see is in the areas of AIs that we are contributing to? So we see that very huge demand in AI chip, that, you know, you need a huge powerful chip to run the, you know, inference model, training models, things like this. So that is huge demand that posed on electronics engineers. And you will see in terms of connection between data centers, we have in the next generation of wireless communication network will be 6G AI convergence, where AI plays at the brain of the network. At these things, you know, we need a lot of engineers working in this area. We have embedded AI system where we can develop systems that deploys the power of AIs to the daily life. So things like roles emerging in 2026, like edge AI architectures, robotics hardware developers, AI engineers, etc., etc. So we all need that kind of person. We have smart energy and you know, EVs startups that we need to work with AI. So we need to incorporate with the system, provide the intelligence of AIs. We can have new areas in medicine and defense that need AI analysis and things that we can provide. And last but not least, the digital twins and IoTs that you know, that replace as we have a connected world, a world between cyber and physical world to do a lot of the good things. We have smart city, industrial, IoTs, and twin platforms that, you know, will create a lot of work jobs for the futures. Those things as motivation behind you know, the fact that we opening this course that offer the engineers the ability to get to the job in these areas. But this is not to name a few. There are many you know, match between those areas that we can see later. Okay, so the message you bring in is that don't just study for the past, we engineer the futures. The AI needs more people. We don't, it doesn't need people to write the code anymore because the AI can do this very well. We need people to build the machine, design the networks, and create physical infrastructure for AI to run on. So that is what we are offering at Middlesex as a Master of Electronics Engineering. We cover a lot of areas that we mentioned earlier: AI 60s, 16 AI native networks, embedded AI system, digital IoTs, signal processing, and smart energy. Those things we will cover in our course. It's a program. We have Professor Mehmet Kraman Cruz, who's head of department, Dr. Purab, the director of programs, and myself at program leaders. The delivery team, we have Professor Huan Nguyen, who is an expert in digital twins, Dr. Ramonas, Dr. Quốc Tân Viên, Dr. Alex Vanokovic, Dr. Kim Tiedlis, and myself. We all deliver those modules that we mentioned later on in the course. Right, this is the overview of course. This is 1 year hands-on master that will give people advanced skill in embedded real-time system, digital signal processing, 5G, 6G communications, digital engineering, AI, MLs, and robotics. So we prepare students for very high impact roles in industries as my colleagues mentioned earlier, we have industrial standard facilities that provide students with real world machines that they can work on the projects, the labs in the daily life. And more importantly, we have active group of members doing research in a lot of areas. We have here Professor Tuan and Dr. Prabsa, who all have excellent projects, funded projects, very huge funded projects and runnings on, yeah, the state-of-the-art research. So we have offer users chance of working with us. Okay, so there are 3 reasons we would like to mention why this course is important to use. We have to emphasize that we have the first research center doing research in digital twin technologies in the UK. And my colleague, Professor Tuan, will introduce later on. We have cutting-edge research on these areas, and we are the first course in the UK offering the digital twin. We embedded this one into the course so that the knowledge-informed research. We have career readies that my colleague Dr. Prabsa mentioned. We have some. We aim to teach our students to have practical experiences in the course that we all have lab based, and the thing that combining the AI, IoT, robotics, a lot of areas into our course to meet real world challenge. Yes, we have 2 routes as mentioned earlier. One is 12-month normal, and another route is that we have professional placement option that a student can add up to be 2 years study, 1 year in university and another years in industrial to further develop their employment and the work experience. Yes, we have different areas that people can touch on, like telecommunications, aerospace, automotive, defense, healthcare technologies, consumes electronics, transportation, and smart manufacturing. And yes, and we have a research center on the twin technologies that can provide you with up-to-date state-of-the-art projects that can work on with our team. Right, so what do we expect this student when we finish the course? As mentioned earlier, that we have plenty of things that meet the AI demand right now. So when you finish, you can work on different company like electronic design for embedded engineering systems. You can work to bring AI on the edge platforms. The company working with making chip, you can work on this one. You can working on telecommunication, become telecommunication engineers to work like Huawei, Nokia, this company providing some wireless communication. You can go on control automation, robotics engineers. You could be trained and IT system engineers. It could be a data engineers focus organization. You can develop a lot of AI stuff, mixing between hardware and software. And of course, many of students can progress to further research like PhD in electronics, telecommunication, cyber physical system, and related areas. And in terms of the program, we have this is full-time program with 3 semesters. In total, we have 6 modules to be run and 1 individual projects. For the first semester, we will learn digital signal processing communication, which is a very important concept in 6G's AI native networks that provide the connection between data centers and signal processing. So if you have a very strong background in terms of digital communication. So for that, you can have skill to work on telecommunication companies. We offer you robot manipulation as another modules to learn about how to manipulate robot, how to make some work, design robot. We offer the digital twin engineering, which is very, as I mentioned earlier, this is the first program in the UK offering this unique modules that backed by our very strong research centers. In semester 2, we will learn machine learning for engineers. We will have a lot of skill in terms of how to design a machine learning algorithm, how to design a network, train the network, and improve the network, which is the backbone of the generative AI right now. And then you go to another modules, which is embedded real-time system, where you will learn how to design an ARM chip to work in embedded to make edge AI devices to bring the AI next to the users. You don't need to run on cloud. You don't need to pay a lot of tokens and things like this. So we deal with those things to make the AI realities, to bring it closer to the massive application. Then we have engineering sustainability to study how we design the whole system in a sustainable way, which is very demanding thing in right now. Right, so that is the 6 modules of 2 semesters, and the final one, which is the into project, which is the heavy one that you can select one of the modules that you desire to work on, and we have staff to help you to do the project. And the project normally is a practical project where we need to build a real thing. Right, so after that you have food master completed. We have another route, which is placement for 24 months. So you have another years to do placement, and we have a team to help you with this one, to find a placement and prepare CV for you guys to apply for the job, and you have visa for 2 years to stay here. Right, so in terms of teaching and learning, so we hands-on learning university, we provide you the project-based approach based on individuals or group projects. So we have modules we can be organized in the three-hour blocks. And within the 3-hour blocks, we have 1 hour deliver the theories, and another 2 hours to connect the theory with the practical labs that it brings out in the real life, how to deal with certain things in practice. For example, we have AIs and machine learning models where we have 1 hour to deliver the math of how to design the network, and then another 2 hours to do the coding to make the transform the mathematics formulas into the code and into the models that work. And so on for embedded systems. For example, we have theories, and then we have practice on, FPGA board and ARM chip, for example, to do programming to make it work. So we have that called research-based approach, where we can divide a group of students to do small projects in X modules, so that it connected the theories into the practice. We offer state-of-the-art facilities that we mentioned earlier. One thing is that it's 100% coursework assessed. It means that students don't have to do any exams. The reason why is that exam is only one snapshot of checking the knowledge and skill. We believe that in real life, engineers need to be practical in terms of solving problems. So exams does not meet the whole thing. So we assess students based on the coursework, meaning that the whole progress of achieving the knowledge and bringing the knowledge into the practice, building the skills is more important to us. So that's why we provide coursework assess. So all based on coursework, which is like a report at the end, the code writing for certain project, and presentation. So those things, what we assess here. In terms of class support, we have technical and tutor support. So everything you need in terms of technical or knowledge, you won't reach to us, and we provide one-to-one support to use. Programming language. So we use two main programming language in our course, Python and MATLAB. So those are the things we teach you, and we use those in our modules. Okay, so we have very state-of-the-art research centers. So I'd like to invite my colleague, Professor Tuan, to introduce the London Research Centers.
Thank you, Tuan. Hi, everyone. I think the idea, okay, we always think that research is so important for learning and teaching as well. So that's why we connect well and connect closely the student learning with our research outcomes and research activity at Middlesex University. So for our London Digital Twin Research Center, we we established maybe about 6-7 years ago, but we has been developing it rapidly. Now, let's say that for example, in the last 2 years, we have secured about more than even £6 million in funding with more than 15 projects. So even currently, we have around 10 projects ongoing, right? So at the core of our research is about digital twinning. So basically, you try to develop a digital version, digital replication of any physical object, subject, process, anything you name it, that you want to study, right? So if you got the digital version, you can always do things that it's normally difficult to do with the physical one, with the real one. So whether that may be a mobile phone network, you cannot interfere with what is a live mobile phone networks there. So, but if you can build a digital version of that, you can always run different what-if scenario simulation. You can test it as a sandbox, many different things. So the digital twin can have many different purposes. You can optimize the process. You can predict problems before it happens. So then what is that then? Okay. It's a mixture of a number of different enabling technologies. So we're talking about the IoT, we're talking about the 5G, 6G as a core connectivity technology behind it. We're talking about visualization, and we're talking about, of course, the AI machine learning as to do some smart thing for the digital twin. So, and also a lot of that doing with the real-time data analysis, real-time monitoring. So therefore, we have plenty of different projects in different applications. For example, we have the project on the healthcare sector. We are currently doing some, we were working with the hospital from Indonesia and Vietnam, working on how we can support the medical doctors in treatment, in diagnosis, and in taking care of the patient in stroke care. So that's one example. We're also working with partners from India to study how the digital twin can support the emerging, not emerging, but the very trendy trend of open radio access network in 5G, 6G. And so that is so important as well. I think all the governments actually wanted to diversify the telecom market, right? So that's important that we make sure our student is equipped with knowledge, with tools to be ready for that trend. Okay, and then if you see that from the module structure, we have almost like the key important aspect there. Nowadays, people talk a lot about AI, right? We talk a lot about AI, but you can see here, we do have the AI element in here, machine learning, but we teach machine learning specifically for engineers. How we can use that, we can make the most of it. But at the same time, some of the key things that Tuan already mentioned, that maybe AI cannot replace those skills in here. We talk about for example, I just give one example, digital signal processing and communication. We teach you the fundamental stuff. At the same time, we also get you up to the level of the latest mobile technologies, for example, 5G, 6G. You can talk about many things, about different things. You talk about AI, you talk about robots, you talk about Industry 4, but you need to have connectivity. And behind that, you have to go with what we call 5G, and now up the next generation is 6G. And if you are on top of that, you will be on top of the world, believe me. Right? That's the reason why I have to say that America, China, and plus the UK and some of the country is investing a lot on how to be leading in the 6G area. So that's important for that. But at the same time, as you know, that automation and robotics is important. That's why you can see that the topic of robot manipulation is taught in this program. And then, of course, now I'm coming back to the digital twinning. You know, it is important that, you know, nowadays we, you know, the digital platform is so important, right? And I mentioned already that the what if scenario run simulation is so important for you to test. If we talk about example, even NASA, right? The one before they launch their spacecraft into this, you know, into the space, they always have to test. They have to run thousand of different scenarios, so that they wanted they don't want any surprise at all. And they cannot just go there and test everything. They have to do that in the digital environment as well. So that's one example. In automotives, in energy, in electricity supply, in many different sectors now, they are investing on the digital twin technologies. And I'm not sure I can share this with you, but you know, we are also has been funded by the UK government to do some important research, which we cannot share openly, right? But we have almost like 4 or 5 million project doing the important topic in the UK. So just wanted to show you that, okay, the digital twin technology is taking off quickly. If you join our program, you definitely will have opportunities to join our projects. We can give you opportunity to get to the latest state-of-the-art research within our center. Right? And then, yeah, maybe I can talk a lot more about the project I mentioned about. We got about 10 or even 12 ongoing projects on the digital twin topic alone. Yeah, and then I haven't mentioned about that. Okay, digital twin for that we also combine with the quantum technology to support the digital twin. That is also important. Okay, maybe I know that time is limited, so I hand back to you, Tuan. But if you want to know more about our center, definitely yes, we're happy to share with you. You're on mute, Tuan. You're on mute.
Thank you everyone for sharing the knowledge and platform that we provide to students via London European Research Centre with plenty of research, state-of-the-art topics that we offer our students to work with us, such as the good chance to catch up with latest technologies in 5G, 6G, digital twin, and robotics, etc. Yes, so there's very successful student from our program. So this is one of students who work, who is his intelligent, and of course he's worked very hard, and he's won a lot of prize from Archbishop's ComSoc, which is very famous, governance society in the world, that he won the first prize in the ComSoc for student poster for 6G technologies. And he was funded for 1 month, I think a few months, working with VRV Solutions, which is the leading company in 5G, 6G in O-RAN, Open RAN. And then he's finished 2 years back. and this is one of those famous students. Right, so the edges and fees are mentioned in the website, so we can go through for detail on that. We have placements and we have scholarship and employment sponsorship available. So everything you can find out on our website. Yes, so if you have any question, feel free to ask us. Thank you so much. So do you have any question for us for the programs? Anything that you would like to find out more?
Betty, Karen.
Yes, hi, Dr. Tuan. Thank you so much for all the sharing, everyone. Yes, let me stop it here for a while. And yes, I will definitely share this